doing trick stuff? That's good.
Can we do another long division?
Yeah, like the long division improper one.
Yeah.
Is there one in the book?
Yeah. X to the sixth over x squared minus 4.
One. Okay. So let's long divide. First of all, that's improper, right?
Yes.
Okay, and it's improper because the power on the top is bigger than the power on the bottom, or the degree of the top is bigger than the degree of the bottom. So if I long divide this, help me out. What goes in the house and what goes outside the house? In the house? Not in my house. You guys know where that's from? I think it was the slogan for the Sonics one year, a couple years ago. We beat the Spurs yesterday. Are they still the Sonics?
They're not the Sonics. That was.
I know.
It's a sore subject.
Yeah.
It's a sore subject. Okay. Okay, so long division. So we want to know what times x squared gives you x to the sixth. X to the, let's start with the x to the fourth, okay, and then you multiply. So x to the fourth times x squared is x to the sixth. X to the fourth minus 4x to the fourth is minus 4x to the fourth, right? Okay. And then, so if you did this right, the first term should cancel out. So switch the signs. Is it easier if I switch the signs or if I put parentheses? What would you prefer? Parentheses? Like that? Okay, that's essentially what you're doing. So the x to the 6 cancel out, and then you have a minus 4x to the fourth is a positive 4x to the fourth. And then do this again because the power here is still greater than there. So what times x squared gives you 4x to the fourth?
X squared.
4x squared.
Okay. I was wondering if I heard that correctly. We need the 4, right? Okay, 4x squared. So multiply 4x to the fourth minus 16x squared. Since I'm being videotaped, I should like talk to the camera, right? So
No, not at all.
So Elizabeth, what do we do next? I'm waiting for you to respond.
It's like Dora.
Yeah.
Okay. So she would say we.
She'd complain about our children.
Instead of talking about this, we'll just like talk about her the entire time. It's really funny. Look what's behind you. So we subtract. And then switch the signs, so we get positive 16x squared. So do we continue or do we stop?
Continue.
Continue because the powers are still the same, right?
Mhm.
So one more step probably. So it's going to be plus 16, and then multiply. You have 16x squared minus 64. Is that right?
Yeah.
And then subtract, and then you're left with a 64. So this equals x to the fourth plus 4x squared plus 16 plus 64 over x squared minus 4. Yes. So the part is rewritten out like that. Is that the 64 over x squared minus 4? Is that okay? Where that comes from? So it's always remainder over the divisor, right? So, so you have four terms. Three of the four terms, the antiderivatives, I think, are fairly obvious, right? So you have x to the fifth over 5 plus, what, 4/3 x cubed plus 16x plus 64 well, times the integral of 1 over x to the fourth minus 4 dx, right? That we can all agree with. Okay. So, you see 1 over something, right? And you're naturally thinking that it should be a natural log. But why isn't this a natural log? Because it's x squared on the bottom. And there's no x's on the top, right? So it can't be a natural log because you take the derivative, right? Or if you take the antiderivative of this, right, you need an x in here to be able to cancel out with the derivative of the bottom, okay? So it's not a natural log, okay? So if it's not a natural log, what is it? It's a trig sub. Or if you don't want to do a so you can do this using trig sub pretty easily, okay? You can do a trig sub here. Or what you could do is, when I look at this, is there an integral that looks like this that's very similar to that you know the antiderivative of? So x integral of, actually that's not, never mind. Let's do trig sub. I was thinking of something else, hoping that we can kind of avoid it. I don't think it would avoid it. So trig sub, if I do trig sub on this one, what would your substitution be? 2 secant theta. Where did the 2 come from? CA, and then it's x squared minus a squared, right? So dx is 2 derivative of secant is secant tangent, okay, d theta. So this is equal to the integral 1 over x squared is going to be 4 secant squared theta minus 4. Dx is going to be 2 secant theta tangent theta d theta. So this is equal to the integral 2 secant theta tangent theta d theta over, factor out of 4, secant squared theta minus 1. So secant squared theta minus 1, that's what?
Tan squared.
Tan squared. Okay. So tan squared, one of those is going to cancel out with the top. And then 2 over 4 is 1/2. I can pull that out in front. And then, so I have secant theta on top over tangent on the bottom, right? And secant over tangent, does that simplify into something nice? Secant is 1 over cosine divided by tangent. So tangent is sine over cosine. If I divide that, that's going to be cosine over sine, right? And that becomes 1/2 integral of cosine. Or or 1 over sine. Do we know how to integrate cosecant?
The natural log of absolute value of sine would it?
That was pretty fast.
We know how to integrate secant, right? So the cosecant, what was secant? What did we do with secant? Because the integrate cosecant is pretty similar. All this for that, my goodness. All this for that one little part. How do we integrate cosecant? First of all, is it cosecant? Is that right? Kind of wish it wasn't, but. See anything wrong with the trig? Just want to make sure before we actually do it. Hopefully is that okay? Yes?
Going back, I kind of got lost where x equals 2 secant theta.
Yeah. So if you go back to the trig subsection, you look at this form, it's of the form x squared minus some constant squared.
Yeah.
So the substitution, x squared minus constant squared, is going to be the square root of this. X is equal to square root of that, which is 2. Square root of 4 is 2, times the secant of theta. If I go back to the previous section. So this is form number 2. It's of this form. See, it's x squared minus a squared. So the a is 2. Does that look okay? Okay, so how do we integrate cosecant? How do we integrate secant?
We multiplied it by like secant plus tangent.
Yeah, on the top and the bottom, right? So what do you think we can multiply on the top and the bottom of cosecant?
Secant plus tangent.
Cosecant plus cotangent or minus? Let's try plus and see what you get. Okay, and so need more space. Cosecant, cotangent over cosecant plus cotangent. Okay, so let's check if this is right. Now, if you remember, if this was secant, you multiply by secant plus tangent on the top and the bottom, right? And then what did we do? We did a u sub, right? And the reason why the u sub worked was because the derivative of the bottom was the top, right? So in this case, what's the derivative of cosecant? With a negative, right? So you have a positive here. Okay, what's the derivative of cotangent? Cosecant squared. Negative or positive? Negative, right? So is this the right multiplication? Or almost the right multiplication? What do you think?
Oh, yes, it was
cosecant minus cotangent. Then you get positive cosecant squared minus cosecant cotangent plus derivative.
So the derivative of the bottom is what? It's going to be negative cosecant cotangent minus cosecant squared, right? Isn't that the top except what?
Minus.
Off by a factor of minus 1, right? Is that okay? Is that okay?
Yeah.
So does this work?
No.
Well, let's try it. So,
Can't we do it and just take the negative sign out?
yeah, that's what I'm proposing. So let me erase this part. So we have, so let U be cosecant cotangent, or plus cotangent. So du d theta is going to be negative cosecant cotangent minus cosecant squared, right? I never differentiate cosecant or cotangent, so I'm like, oh. And then you can factor out a minus 1. Okay, and can you see how this is now that, right? On the top. And so we have this integral becomes the integral of cosecant squared theta plus cosecant cotangent over u, and then du, or d theta is going to be du over minus cosecant theta cotangent theta plus cosecant squared theta. And so see how that cancels out? But we have this minus sign that you can pull out in front. Okay? And so, I'm going to come over here now. What's the integral of cosecant?
Minus the natural log of the absolute value of cosecant theta plus.
Times minus the natural log, the absolute value of cosecant plus cotangent. Plus c. Okay. And then, so we need to plug in what cosecant is. So you draw in a triangle. So x is equal to 2 secant theta. So that means that secant theta is x over 2, right? So what is x? What is 2? So secant is hypotenuse over adjacent. So it's going to be x over 2. This is going to be the square root of x squared minus 4. And so, I feel like one of those instances where I'm like writing with one hand and then erasing with the other. Not because I have a lot to write. Well, I do have a lot to write, but it's because I don't have enough space. I'm like an artist without a blank canvas to work with. What do I do?
I lived by a guy who just had like this giant wall that he painted, and he just kept painting it. He'd just sit there in his living room, and he'd just paint something, and then he'd
over and
look,
over again?
and he'd paint something, and he'd like it for about a day or two, and then he'd just keep painting it.
I hope this is okay to follow. So we're going to go over here. Minus 1/2 natural log, the absolute values. Cosecant theta, let's look over here. So it's going to be x over the square root of x squared minus 4. plus cotangent is going to be adjacent over opposite, right? 2 over square root of x squared minus 4 plus c. And then we want to fill this in there. And so negative 1/2 times 64 is a negative 32. Does it annoy you that you have 4 parts? 3 of the 4 parts take like 2 steps, and then the last part takes like 10.
Can you factor the x squared minus 4? Like, instead of doing the tricks?
Yes. How come you didn't say that earlier? So this one, this one you can write this as x plus, well, not a plus x plus 2, b times x minus 2, and do a what?
Partial fractions.
Oh my god.
How come you didn't say it earlier?
Can we do it that way now?
That's actually okay if you didn't see it. But while you're doing it, you're like, oh, how come we do it that way? Well, you could. Partial fractions would have been so much easier, I think. Although, it doesn't look quite the same, but that's okay. Because you're going to have a natural log over x plus 2. Yeah, I prefer doing it partial fractions. Well, I wasn't liking. Cool. Did the book do partial fractions on that one?
They didn't even ask us to integrate that.
What?
All I asked for was long division.
Oh, really? Oh, okay.
What number was that?
5.
Write out the partial fraction decomposition. That's it. Okay. Well then.
Yep, they probably wanted you to avoid all that.
In that case, that. Cool, that was fun. Did I answer your question?
And then some.
This is what happens when you're not here. It was a good. I don't think it was a waste of time. I thought it was a good exercise. If that was x squared plus 4, then I think you could have actually avoided trig sub. That's the part where I'm like, oh, you can actually think of that as an arctan or something. Okay. X squared minus 4, you totally could have avoided trig sub because that could factor. So I didn't see that beginning, obviously. Okay. Who mentioned trig sub?
Not me.
Was it me? Oh. Go back to the video and see. All else fails, I'll just blame it on him. Because he's such a nice guy. Are we okay with the long division part? That's not something that I covered in this class. That's kind of a prerequisite. Okay. So let's go back to the problem we were doing yesterday, and I want to finish that out. So it was, which one? What was the integral? The integral of
It was integral of 18 over x plus 3 times x squared plus 9.
part C, right? The integral of 18 over x plus 3
times x squared plus 9.
Okay. And then we did the partial fractions on this, and we ended up with what?
We got down to the square root of 1 over x plus 3 plus negative x plus 3 over x squared plus 9 dx?
Wait, where'd you get the square root?
No, I didn't say. Did I say square root?
Yes.
Oh. Oops.
Oh, you mean the integral of 1 over x
Oh, yeah.
1 over x plus 3
plus
plus.
negative x plus 3 over x squared.
Okay. We got to that part after we did the partial fraction, solve for a, b, and c, correct? Okay? And so now we can break this up essentially into 3 integrals. So we have the integral of 1 over x plus 3. Is that obvious? Okay? Plus, now this one, again, this looks like the integral of negative x plus 3 over x squared plus 9. You don't want to do, you can't do another partial fraction there because x squared plus 9 is an irreducible quadratic. In which case, if you do partial fractions on an irreducible quadratic, you're going to get the same thing on top, right? So, and then u sub I don't think works, right? And so, my suggestion is we should break this up into 2 integrals. So the first one looks like that. And the second one looks like that. Is that okay? Now, the first 2 I think are okay. At least the first one, that's going to be the natural log of the absolute value of x plus 3 minus, how would you evaluate this one? So now you have an x squared plus 9 on the bottom, you have an x on the top, right? So the integer of this is what? Would it be a trig sub or would it be a u sub?
Could you u sub?
A u sub, right?
Yeah.
So we let u be
X squared.
x squared plus 9, right?
Can you do a trig sub on that?
You can, but I think it's much harder. Okay? Let u be x squared plus 9. Du dx is equal to 2x. And so the 2x, that x, and that x will cancel out. And then you'll have a 1/2, right? After you make that substitution in for dx. Can you see that?
Mm-hmm.
Okay? And so you have the 1/2 out in front. You're going to have the natural log of the absolute value of u plus c. Plug in u. So it's going to be minus 1/2 times the natural log of x squared plus 9. In this case, you don't need absolute values because x squared plus 9 will always be positive. Okay. So in this case, just kind of as a heads up, right? When you do a u sub, you'll get a natural log, right? If you can't do a u sub, you're probably not going to have a natural log. Does that make sense? So that's kind of something to keep in mind. Plus, this one is what? That one you can do a trig sub. Or, this is where I wanted to go with that one, which didn't work. Or, you can think of this as an arctan of something. And the reason is, recall, 1 over x squared plus 1 dx, the integral 1 over x squared plus 1 is equal to arctan, right? Okay. So, is there a way to make that look like that? So if I have 1 over x squared plus 9, is there a way to make that look like that? So in other words, how do I make this 9 into a 1? How do I make that 9 into a 1? Divide by 9, right? So this is going to be 1 over 9 over x squared over 9 plus 1, correct? So this is going to be 1 over 9 times 1 over x squared over 9 plus 1. Which is equal to 1/9 times 1 over x over what squared plus 1. What goes here?
Point the 3. Do we have to keep the 3 up there?
I'm ignoring the 3 for now.
Oh,
Yes.
Why, when we're factoring out the 1 over 9, do we still have x squared and over 9?
Because that 1/9 is
Oh,
for the
yeah,
column.
okay.
Is that okay?
Yeah, okay.
So this is x squared over 9 plus 1, x squared over 9 plus 1. If I want this thing as something squared, this is going to be x over what? 3, right? Is that okay? Okay, so now let's do this.